Good morning to all of you. I'm Malithi Rajapaksha. Today my presentation, the research presentation is titled Evaluation of Solar Potential by Domestic Building Typology. So, of domestic buildings in Colombo, Sri Lanka. So we were doing this presentation, or the research was based on building typology. And moving into the research background, the research location we selected was Colombo, Sri Lanka. And Sri Lanka, as all of us have experienced, is a country, is an island which receives plenty of solar radiation throughout the year. Right? So, though we receive enough of solar radiation, it's the utilization of so photovoltaic panels still in its early stages of generation. And hydropower already accounts for 27.9% of the total electricity generation. So there's possibility to implementing government tariffs to encourage photovoltaics. So further actions also taken to encourage this photovoltaics in Sri Lanka, as it has potential. So why we selected Sri Lanka for this study is Sri Lanka's total energy requirement for a year is around 11,125 kilotons oil equivalent, as per the statistics we got in 2015, right? So out of the total energy requirement, 56% is from indigenous resources, and the rest 44% is imported as fossil fuels. So for this importation, we cost $5 billion per year, and that cost is 25% of import expenditure and 50% of total export income. So can you imagine, or can you understand the criticality of this situation, what we waste for importation of energy, right? Okay. So this was the situation is because we have a huge large-scale power station in Norachole, but we know that it faces several breakdowns from its beginning. So now at the moment it's not in a practical situation using this Norachole power station and having energy to the national demand. So there's a requirement to put regional power outages all around the country to fulfill this energy demand. So Sri Lanka expects an increase of overall annual demand electricity by 4 to 6% in the future. So government has identified this potential of energy increase in the future, and as a solution, they have identified the need to go for green energy solutions. So increase share of electricity generation from renewable energy sources from 50% in 2020 to 60% by 2030. This is what the government is predicting to have in the future, and they predict to reduce the carbon footprint of the energy sector by 5% in 2030, and ultimately be a self-sufficient nation with energy in 2050. So to fulfill this, to achieve this target, they have listed out objectives and listed out these objectives, and now we are moving into our research objectives. This research, so in order to conduct this research, in order to determine the existing radiation models, then as the second step, we surveyed several neighborhoods in central Colombo. Was conducted in order to identify characteristic building forms and their dimensions. Then Rhinoceros tool, which is a simulation software, was used to model the basic domestic buildings, and coupled with the grasshopper plugin and ladybug, there's a tool called Honeybee. So we use that as well in order to analyze the roofs in terms of incident solar radiation. Then the surface area to volume ratio of the building were calculated as a measure of thermal efficiency of the building. So that's how we evaluated, or that's how we calculate the thermal efficiency of the building. Then moving into the methodology. For the domestic survey, we used Google Maps to utilize to examine 4 neighborhoods in the Colombo area to identify domestic building typologies. So these are the 4 neighborhoods we identified. One was from near Ward Place and Independence Square, Palm Grove and Cadris Road. These are the 4 neighborhoods. So out of these 4 neighborhoods, 6 characteristic buildings were identified. These are the 6 characteristics which we identified as the samples. Their dimensions were obtained as shown as in this table. These are the dimensions of them as we identified. And then for solar irradiation, simulation was done for these 6 types, and it was done using the simulation engine called Radiance, which was integrated in Rhinoceros 5 via the Grasshopper plugin and Ladybug and Honeybee tools. And actually, the Ladybug imports the weather data on the program. That's the task of the Ladybug tool. And whilst Honeybee connects user interface of Grasshopper to 4 simulation engines which help to evaluate environmental performance. So the 4 simulation engines we used are Energy Plus, Radiance, DaySim and one Open Studio, which evaluates building energy consumption, thermal comfort and day lighting. These are the things we evaluated using the above mentioned simulation tools or plugins. This is the process which we adopted. This is the how the Grasshopper and Honeybee radiation analysis in the simulation tool interface is visible. And these slides showed you how it's neural network used on Grasshopper for the radiant analysis. So coming into the results, what we found by this research. So these are the results as you visit, which we can visualize with colors. The simulation was run for all 6 types of buildings, and the results obtained are shown as in 6 types. So the surface area to volume ratio were calculated for the 6 houses. This ratio was used as an indicator of thermal efficiency of the building as a very simple method. So building with higher surface area to specific volume would have more fabric area available for heat transfer, therefore making it less thermally sound. So the buildings which have surface to volume ratio less is more successful, were more successful according to the results. And so according to that analysis, building type 5 was the most successful building typology out of the 6 building typologies. Building type 5 was the best in terms of thermal efficiency as it had lower surface area to volume ratio. Also, it exhibited higher amounts of incident solar irradiation, which means it is more favorable for photovoltaics or installation of solar thermal roof plants. This is the conclusion what we came at the end of the research. This research was conducted as a summary. This research was conducted in order to identify prevailing domestic building typologies in Colombo and analyze them in terms of building efficiency and solar potential. So we did a survey to find 4 neighborhoods in Colombo, and then we found 6 characteristics out of those neighborhoods. Then a radiation analysis was conducted using grasshopper, as I said earlier, coupled with ladybug and honeybee tool, and an analysis on surface area to volume ratio revealed that building typology 5 is the best in terms of available rooftop solar potential and thermal efficiency. So at the end, as recommendations, we can recommend for the future research, as I said earlier, we use Energy Plus, but as recommendations, use of Energy Plus in order to run comprehensive energy consumption analysis on the building in order to obtain a deeper understanding and quantitative results regarding the thermal efficiency of the building. So if someone is extending this research further, our recommendation is to use Energy Plus tool in a more efficient way. So that will lead to a better identification at the end. Thank you.